So welcome back. We're now on chapter 1.6 in the grade 7 textbook, which is on square roots. Square roots are pretty tricky for a lot of students because it does involve a lot of guessing or working backwards with something that we just learned on exponents. So let's just look at the definition, or let's look at what square roots means. Well, a root means the original part of it. So like the root word of something, it's the original part of that word. And so square, as you know, is a two-dimensional flat surface where the sides are all equal. And then the angles are 90 degrees. So in this case, this is a square. It's a rough representation of a square. It has a certain area of it. So in this case, the area is 1. The square root means what is the original dimensions of this square to get the area 1. So what do the dimensions have to be? What times what has to give 1. So 1, if we try out several numbers, or if we just know that 1 times 1, one side length times one side length, gives an area of 1. So the square root of 1 means what is the original dimension, or one of the side lengths, and that's 1. If I now look at another square that's divided into 4 smaller squares, such as this, there's no other squares in between this and this. You either have one square, or now I have different dimensions on the side, and that's a 2 by 2 square. So the square root of 4 is the whole number dimension, which is 2 on each side. I can continue on, or you can use a calculator as well. The calculator function is this little button that looks like a check mark. That's the square root. It tells you what is the length of one side that, when multiplied by itself, gives the full area. So for example, on your calculators, I have 9 blocks which arrange to a square such as this, and I want to know what is the dimensions of one of the sides. So the dimensions of one of the sides, I use my square root button. So the square root of 9, on my calculator, I have to press the square root button after my number. Sometimes some calculators you have to press it before. So make sure you know how to use your calculator appropriately so that you can get the correct answers. So in this case, you look at here, the square root of 9 is 3. Just take a moment to pause the video and find out the square roots of 36, and find the square root of 121, and find the square root of 10,000. And the last one, find the square root of 20,000. After you've tried this, you see that the square root of 36 is 6, the square root of 121 is 11, the square root of 10,000 is 100, and the square root of 20,000, well, I'll do this with you, is 141.4 approximately. 141.4. We notice here that this is a decimal. Well, that basically means that we have half of a block, or in this case 4/10 of a block, that's extra to make a total of, when added together, 20,000 blocks. So this is a funny one because it doesn't have an exact number of blocks. The ones that do have exact number of blocks on each side, or whole number dimensions, we call these perfect squares. So a perfect square is a number with a whole number square root. In other words, a perfect square is a number that, when you find the square root, it has whole number dimensions to it. So let's list some of them. The first perfect square is 1. The next whole number after 1 is 2. So the next perfect square is 4. The next perfect square after that is 9. The next whole number after 3 squared is 4 squared. And so the next perfect square is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 9 times 9, and that's 81. And 10 squared, change that a little bit, is 100. And if we keep going, 20 squared is 400. And we see a pattern here that 30 squared is really 3 times 10 all squared. So 3 squared is 9, and 10 squared is 100, so that makes it 900. And we can continue on this trend. As long as we know the squares of 1 to 9, we could actually predict the squares, or the square roots, of a whole lot of numbers. So the first question would be, is 65 a perfect square? And if we look on our chart, 65 doesn't fall anywhere, or it doesn't appear. So we know that it's not a perfect square. Well, what would be the square root of 65 then? So the answer is no, because it doesn't appear here. It does not have a whole number square root. But it should be approximately something. We see that it falls in between 64 and 81. So that means the square root of 65 has to fall in between 8 and 9. And because it's closer to 65 is closer to 64, I can guess approximately that the square root of 65 is about 8.1. That's a reasonable guess, or I could say 8.2, 8.1, because it's fairly close to 8 squared, being close to 65. Next question is, if I have the square root of, let's say, 225, well, the problem is I don't have that on my chart anywhere. However, I can guess it's in between 10 and 20. Because 10 squared is 100, 20 squared is 400, so we know that the square root of 225 has to fall in between this range here. But here, if I tell you that 225 is a perfect square, then I can guess. Look at the last number. The last number is a 5. The only number, the only whole number that gives 5 as a last digit is 5 squared. So my guess, or my estimate, is 15. So another example that I'm going to use is the square root of 441. Well, that doesn't fall within our range either, but let's take a look where it would fit. Well, it fits in between 400 and 900. That means the answer must be between 20 and 30. So it's between 20 and 30. Because it's between the answer, the original question is between 400 and 900. Now the question is, what is the last digit? Well, the last digit's a 1 here, and let's look through our list and see which ones end up with a last digit of 1. Well, 1 squared gives a 1, but also 9 squared gives a 1. So possible answers will be, and it has to be between 20 and 30, are going to be 21 or 29. The reason why I choose 21 or 29 is because 1 squared gives a 1 as a last digit, and 9 squared gives 1 as a last digit as well. Well, let's take a look then where it falls in our chart, and we see that 441 is actually much closer to 400 than it is to 900. So that means my guess will be 21, because 21 is closer to 20 than it is to 30. And so then I can use my calculator and try out the square root of 441 is indeed 21. So my estimate was correct. So just to recap, a perfect square is a number that has a whole number square root. Not every number in our number line is a perfect square. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, but all the numbers in between, 2, 3, 5, 6, 7, and 8, are not perfect squares, because if you square root them, you won't get a whole number dimension. You'll get some decimals in there. Next, if you're trying to estimate, what you can use are your anchor numbers. So our checkpoints, our key numbers are 10 squared, 20 squared, 30 squared, etc. And then we can look at our number to see whether it falls in between that range. Lastly, we look at the last digit. If we see a 5 as our last digit, then we can guess that maybe the square root will also be a 5. Or I can see if it's a 1, it could either be a 1 squared or a 9 squared. And if you can see if it ends in a 4, then it could be 2 squared or 8 squared. If ends in a 9, it could be 3 squared or 7 squared. Or if it ends in a 6, it could be 4 squared or 6 squared. We'll take a look at some examples during class the next day. So hope you understood the lesson.